GATE 2015 Civil Engineering Set 1 question number 39. A water tank is to be constructed on the salt deposit shown in the figure below. A circular footing of diameter 3 meter and depth of embedment 1 meter has been designed to support the tank. The total vertical load to be taken by the footing is 1500 kilonewton. Assume the unit weight of water as 10 kilonewton per meter cube and the load dispersion pattern as 2 vertical, 1 horizontal. The expected settlement of the tank due to primary consolidation of the clay layer is in mm. Reference to the relevant NPTEL courses or video has been cited. Now coming to the useful data for finding the settlement due to any shape of footing, we have four-step method. To find the expected settlement, the first step, which is finding the H0, where H0 is the thickness of compressible layer. As we can see in this figure, we have clearly shown that the footing is resting some df distance below from the ground level, and here for example we have taken the whole soil as clay, so we can say that we have to find the effective stress at the center of the this compressible clay layer. So to find the sigma 0 at the center of compressible layer, where sigma 0 is the effective stress before application of load at the center of the clay layer. Now in the third step we have to find delta sigma, where delta sigma is the increase in effective stress due to structural weight at the center of the clay layer. As you can see here, Z is the depth of soil below till the center of the clay layer, where H0 is the thickness of compressible soil. Now we can say that delta sigma will be load upon area. Now if the load is given is in kilonewton per meter square, we will simply multiply it with B into L if it is rectangular footing, and the area will be calculated as B plus 2nz into L plus 2nz, where n is the coefficient of horizontal. If it is given as if the slope is given as 2 vertical 1 horizontal, the value of n will be simply 1, and z is the depth of soil below footing till center of clay layer. As we have shown here that from CC, this is the center of the clay layer. Now if we are provided circular footing, the delta sigma will be calculated as q upon pi by 4 d plus nz square. If the load is given in kilonewton, there is no need to multiply it by area. Now in the fourth step we will find the expected settlement, and the equation we know that delta h upon h0 equals to cc upon 1 plus a0 log sigma 0 plus delta sigma divided by sigma 0, where cc is the compression index and delta h, which we have to find, that is expected settlement, and h0 is the depth of clay layer, and e is the initial void ratio. Now coming to the video solution part, as we can see in the question that here it is a circular fitting whose diameter is 3 meter and a 1500 kilonewton load is acting above this soil. Here in the question it was given that the footing is 1 meter below the ground level, as we can see here. So we can say that the footing is somewhat 1 meter below the ground level, and here 1 meter above the sand layer, we can say. And as we can see here that the sand and the clay layer are submerged. As we can see that the groundwater table is 2 meter below, and the compression index given in the question was 0.3. Now if you solve it, the first part using the four-step method, the first thing which we have to calculate is h0, which is the thickness of the compressible layer, which is clay here. So as we can see here that h0 is 10 meter, so thickness of compressible layer is 10 meter. Now coming to the second part, we have to calculate sigma 0. Sigma 0 is our effective stress before the application of the load. As you know that effective stress sigma is density into total width of the soil medium. So it will be, for the first layer we can calculate is, here unit weight is 15 into, and the thickness is 2, so it will be 15 into 2, plus for sand we can say that the sand layer is submerged, so we have to take the submerged unit weight. So the submerged unit weight is nothing but this is gamma set minus gamma w. So we can write 6 into 18 minus 10, which is our gamma submerged. At the center of clay layer, it will be 5 into 18 minus 10 meter. So our effective stress before the application of load will be 118 kilonewton per meter square. Now in the third step, we have to calculate the effective stress after the application of load at the center of clay layer, and for this we have the formula Q upon 5 by 4 D plus NZ square. As you can see in the question that Q is 1500 kilonewton, which was given in the question, and pi by 4 into the diameter given is 3, plus as we have said that the load dispersion pattern given in the question is 2 vertical 1 horizontal, so n will be 1, so it will be 1 into z is the total height below footing up to the center of the clay layer. So we can say that this is 5, this is 6 plus 1, so 5 6 plus 1, this is 12 meter, so this is 12 meter square. Now if we calculate it, it will be 8.488 kilonewton per meter square. Now in the first step, we have to calculate the expected settlement. So the formula for which is delta H upon H0 Cc divided by 1 plus E log sigma 0 plus delta sigma divided by sigma 0. Now if you put the values, we will get now if you put the H0 here, H0 is 10 meters, so it will be like delta H equal to 10 into 0 0.3 1 plus the initial value is 0 0.7 into log sigma 0 was 118 plus 8.488 divided by 118. Now if you'll solve it, the answer will be in meter, so that will be 0 0.05326 meter. If you multiply it by 1000, it will be in mm, so it will be 53.26 mm. So this is the expected settlement we will be getting. So the answer for the question will be around 50 to 55 mm, somewhere in between. So the answer which we are getting is 53.26 mm. Reference to the relevant NPTEL courses or video has been cited.